Hey everyone, welcome to the last chapter. You've made it all the way to chapter 9, which is different types of functions. And the very first type of function we're going to talk about are parametric functions. Parametric functions are two variables with time. So x is its own function and y is its own function with relation of time. It can be used to describe motion that is not a function. So imagine if you had a particle that did this. You couldn't write a function for this because it fails the vertical line test. So you have to use x of t and y of t. If f and g have derivatives, then there's also a derivative of t. The majority of the time that you see a parametric question, they're going to ask you for the slope. The slope is the derivative of y divided by the derivative of x, which makes sense because they cancel out the dt's. The second derivative is the first derivative divided by the derivative of x. Now that's really important. To do the second derivative of a parametric, it's not second derivative of the top and second derivative of the bottom. It's the first derivative of the whole of the top divided by the derivative of the bottom. So let's take a look at this. Find the second derivative of t if x equals t minus t squared and y equals t minus t cubed. First step, find the first derivative. Derivative of the top is 1 minus 3t squared. Derivative of the bottom, 1 minus 2t. So that's not too bad. Find the derivative of y of x with respect to t. So now I need to take the derivative of y with respect to t. So what is the derivative of this thing? It's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. If we clean that up a little bit, let's see what we get. We'd have a negative 6t plus 12t squared. That's minus 2, so that's going to be plus 2. It's going to be plus 6t squared, so minus 6t squared. So we would get a 12t squared minus 6t plus 2 all over top of 1 minus 2t quantity squared. So that's the derivative of y with respect to t. Sorry, too many parentheses. Now, we take what we just found. Is that what I just found? No, sorry. That should be 6t squared. Sorry. What we just found and divided by the dx dt again, which just makes that cubed. So again, let me stress this. This is not take the second derivative of both things. Take the derivative of the top, take the derivative of the bottom, that's your first derivative. Take the derivative of that, put it on top, put d of x on the bottom, and that's your second derivative. And then it would keep going like that. That's where the majority of parametric questions will be on an AP test. The vast, vast majority. Some other formulas that you need to know, and we're not going to do practice problems on them. The length of a parametric curve looks just like what you'd expect. It's the Pythagorean theorem. The derivative of x squared plus the derivative of y squared, square root, and integral because you took the derivatives. You'll see those every now and then. That's not too rare. So know that formula. These come up extremely rarely. They're surface area. 2 pi y square root of the length or 2 pi x square root of the length. Depends on which way you're revolving it. But that's it for parametric functions. So a lot of it is just finding the derivative or finding the length, mainly finding the derivative. If you have any questions, come talk to me.